Okay, let's go ahead and work on section 3.4. We're going to actually skip section 3.2 and 3.3, so we're going directly from 3.1 to 3.4. There's no homework in 3.2 and 3.3, so you'll just see in my math that section 3.1 and section 3.2. Okay, we just don't have enough time to do all kinds of different probabilities, so we're just basically covering what we need to in order to understand in the previous sentence.
That's 3.1 and 3.4.
3.1 and 3.4. 3.2 and 3.3. Yeah, there's nothing. There's no homework. There's nothing in my math class. So just follow the sequence and the homework. I can show you. Okay, so we're skipping 3.2, 3.3. We're doing additional topics in probability and counting. So we're going to learn how to find a number of ways a group of objects can be arranged in order. And then the number of ways to choose several objects starting from a group without order. So there's going to be a formula for with order and without, and then we're also going to use counting principles to find probability. So we're going to use these formulas to get the probability of events. Okay, most of them will be classical or theoretical. Okay, now. The first thing is, a permutation is an ordered arrangement of objects. So when order matters, it's a permutation. Okay? When order doesn't matter, it is a combination. Now, we'll get to combinations in a few slides. Okay? The number of different permutations of n objects is n factorial. Okay? So, where n factorial is, you start at the number, like if it's 6 factorial, you start at the number 6 and you go and you keep on getting all the numbers. 1 less is 5 times 4 times 3 times 2 times 1, all the way to get to 1. And when you multiply all those numbers, in this case, you would get 720. So you start at 6. So 4 factorial, you start at 4 and go down to 4 times 3 times 2 times 1, which is 24. Okay, now, the reason why this is so important is, if you have 4 books, and you're arranging them in order on your shelf from left to right, how many different arrangements are there of those books? Well, the first choice is what? You use one. The first book, you have what? 4 choices. Now, you used 1. So when you put the next one, you only have 3 choices, and then what? 2 choices and 1. By the principle of counting, you multiply, so there would be what? 24 different orders of 4 books on the shelf, different orders. Okay? So factorial. Now, on the calculator, there is a factorial key. You don't need to do 6 for 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Here it is. You put the number 6, and then you go over to the math key, which is right below the first column, below the green alpha, the alpha. And then remember, what are we doing? Probability, right? So use your right arrow key 3 times, highlight probability, and the exclamation point is a factorial, which is number 4. So you can just hit number 4, or you can scroll down. It's shorter to hit number 4. There's the factorial sign. Hit enter, and it does it. Now, it doesn't show you 6 times 5 times 4 times 3 times 2 times 1. It just gives you the answer, which is 720. 20. Did you want to borrow?
Yes, sir.
Okay. You guys get the sequence on the calculator? So for math, use the right arrow key 3 times to highlight probability, select number 4, exclamation point, which is a factorial, and there's 4 factorial is 24. 4 times 3 times 2 times 1.
Okay. Can I do 6 times 5 times, and when I get to 4, I force it to go back 4. So I say, if I do it like this, then I do 6 times 5, and I force this. I force 4, I don't need to check 6 times 5 and 6 times 4.
Oh,
So
yeah, that's fine, yeah. But I mean, yeah. But you can just do it directly. Okay. Example, the objective of a 9x9 Sudoku number puzzle is to fill in the grid so that each row, each column, and each 3x3 grid contains digits 1 through 9. How many different ways can the first row of a blank 9x9 Sudoku grid be filled? It's only what? The first row, right? It's just the first row. How many positions are there in the first row? First, each row has what? Yeah, 9 positions, and you can use the numbers 1 through 9. So actually, the first one, there's how many choices? You pick one number, but there are how many choices? 9, and then you can't use it again. So then there's what? 8 choices, 7, 6, 5, 4, 3, 2, and down to 1, right? So the answer would be 9 factorial. It's got to be the number of ways. So on the calculator, you would just do what? 9 math over to probability. Number 4 is factorial. And there's your 362,808. You got it? Okay. Permutation of n objects taken r at a time is going to be the formula n factorial divided by n minus r factorial, where r is less than or equal to n. Now, the calculator has this formula built in. Okay? So, you will not have to do the problem using the formula. You'll just hit keys on the calculator. It will use this formula and it will automatically get the correct answer for you. So I'm not going to spend too much time explaining the formula. Okay? So, finding the number of ways of forming a 4-digit code in which no digit is repeated. Okay? And we'll assume we got the digits 0 through 9, which are 10, right? Okay, now, what you have here is, first of all, does order matter? Let's say your code is, I don't know, you pick the numbers 9, 7, 3, and 2. Do you have to get the right order to open the code? Well, no, I think the code, the digit, the order matters. Like if I put in 9, 3, 7, 2, it's not going to work. So the order does or does not matter. It does matter, yeah. So order matters, so it's a permutation, right? Okay, now what? The permutation, we have 10 numbers to work with, right? We can use 0. P for permutation, and we're selecting what? How many? The code is what? 4 digits, so we're selecting, the R is 4. So if we were selecting 6, then it would be what? 10P6. Okay? So now, 10P4, the calculator's got that formula built in. So what you can do is you can simply, here's how you do permutation. You put in the number, the total number, 10. You go to the math, you go over to probability, highlight probability by using the arrow key 3 times, and then NPR is number 2. So select number 2, and then what? Put in the number of selections, which in this case you're selecting 4, hit enter, and there's your answer, 5,040. Again, it doesn't show you the work, but it gives you the right answer. Okay, you guys get it on the calculator, the NPR? No, it's X minus X. Okay.
Do I need the code, sir?
I'm recording this session. Can you wait about 15, 20 minutes? Yes, you mind? All right. Okay, now. Okay, another example. 43 race cars started in 2007. The 2007 Daytona 500. How many ways can the cars finish first, second, and third? Okay, does order matter here? Is there a distinction between first, second, and third? Yeah, usually the word person, right? So order matters, right? So it's a permutation. How many total cars are there you're working with?
43.
43 started, and what? We're picking first, second, and third, so we're selecting three order matters, so it's what? 43P3, right? So 43, math, the right arrow 3 times the highlight probability, and then number 3, the R is 3 selections, and we get our 74,046. Okay, now, you can, when order doesn't matter, it's a combination, and you can't just apply the principle of counting and get the right answer, but for permutations, you can. It's just a principle of counting. You got 3 first place. How many choices for first place? 43, right? Somebody gets first place. This orientation. It's not orientated very well. Okay. You've got, I'm going to quickly orientate. Okay, so it's going to make okay, so you got first, second, third. How many choices for first place? 43. Now what? Somebody got 43, somebody got first place, so how many choices now left for second place?
42.
Yeah, 42, and similar reasoning there is what? 41 choices for third. But now what do? We stop, right? Because it's only first, second, third. Well, if you do what? 43 times 42 times 41, and there's your answer. So you can apply the principle of counting. It's just, what they do is when you put 43P3, they take 43 minus 3, which is 40, and they take all the 40 down to 1, 39, 38 off, and you get it. Yeah. So that's another way of doing it. That's what you were talking about. Okay? Now, distinguishable permutation. The number of distinguishable permutations of n objects where you have duplicates, n1 are of one type, n2 are of another type, and so on, is you take the total number, you factorialize it, and you divide by the number of duplicates for each one. Okay, now, you have to do this one. This formula is not built in, but you do have factorials. We'll do one, and you'll see how to do it. So this is when some of the objects are the same. So here's an example of that formula. A building contractor is planning to develop a subdivision that consists of 6 one-story homes, 4 two-story, and 2 split levels. How many distinguishable ways can the houses be arranged? Okay, now, if they were all different, then the answer would simply be what? 12 choices for the first one, then 11, then 10, it would just be 12 factorial, right? But, what do you got? 6 one-story. So, the number of ways of getting one-stories in different sequences you're losing, you can't distinguish, is what? 6, 5, 4, 3, 2, and 1, right? Yeah, so then what do? You divide 6 factorial. And then you have what? 4 two-stories, so you divide by 4 factorial, 2 split levels, which is 2 factorial. Okay, now it's factorial. It's not dividing by 6, but it's 6 factorial. Okay, so what you're going to do here is on the calculator, the fastest way is what I usually do is I just keep on do this big one and then just keep on dividing. So you don't have the formula built in, so but you do have factorial. So you do 12 math, and then go over to PRB. Factorial is number 4, and you get 12 factorial, right? Some big number. Then what are you going to do? Divide by what? 6 factorial. So divide by, I'll just do one at a time. 6 math, PRB, factorial, and I get that number. Now, 4 factorial is what? So we don't have to go back to 4 factorial. 4 factorial is 4 times 3 times 2 times 1, which is, 24. So let's just use 24. We know what it is, right? We'll save a few keystrokes. We don't have to put it. So now we're going to take that answer, divide by 24, right? And then 2 factorial is what? 2 times 1, which is 2. That happens to be just 2. So divide by 2, and you get 13,860 distinguishable ways. Okay? when you get some of the objects are duplicates, you got to do the factorials. The total number in the numerator and divide by the duplicate factorial size. 6 one-story, 4 two-story, and 2 of the split level. Okay? Combination. Are objects from a group of n objects without regard to order. There's the formula. You will not need to know the formula because the calculator has it built in. There's NPR and NCR. NCR is number 3. We'll do it in a minute. So you don't need to worry about the formula. Okay, now. Okay, a state department's transportation plans to develop a new section of interstate. The highway receives 16 bids for the project. The state plans to hire 4 bidding companies. How many different combinations of 4 companies can be selected? Okay, so let's say there's companies A, B, C, D, E, F, G, and it keeps on going, 16, right? Now, what are they going to do? They're going to select what? How many? Well, no, total 16. They're selecting what? Plans to hire 4. Okay? So let's say they take A, I'm just saying C, E, and G. Those are the companies they select. But now, what if the order was A, E, C, and G, different order? Do they still select the same 4 companies? Yeah, so why? This is the one, so this is the one where what? Order does not matter. Yeah, so it's a combination. See it? Now, this is really important because you gotta, if order does not matter, it's a combination, right? You gotta hit the right key in calculator. That's not making a big deal about it. So the total is, again, 16, similar to permutation, but now we're going to use C for combination, and we're selecting 4 companies, so it's what? 16C4. This order does not matter. Okay? So you could probably figure out the sequence very similar to what we did. 16 math over to PRB. Combination is what? 3. So if I hit number 3, you put in the number you're selecting, 4 companies, and there's your answer, 1,820. And they do it with a formula. What happens is there's not as many combinations. So you do 16 factorial, and then you do divide by 12 factorial, which is the n minus r, but then you have an extra, the 4 factorial, because there's 4 times 3 times 2 times 1 different ways of the different orders you got to get rid of them. So that's why you got to divide by an extra factorial. Okay? Okay. All right, let's put it all together. Let's do a probability problem. A student advisory board consists of 17 members. 3 members serve as the board's chair, secretary, and webmaster. Each member is equally likely to serve any of the positions. What is the probability at random, the 3 members that hold, what is the probability of selecting at random the 3 members that hold each position? So you got chair, secretary, and webmaster. You got to pick each one of those, right? So you got to get what? You got a choice of picking one sequence, right? Of getting each one. Now, you got to say which one's the chair, which one's secretary, or which one's the webmaster. So does order matter? They all have different jobs, so order does matter, yeah, because you got to pick the first one. You can't just pick 3 because you got to pick the first one. Automatically, it's got to be the chair, right, or secretary, how you designate it. Order matters. So what? Permutation. We have a total of 7, and we're selecting 3, right? That will give us our total. So 17P3 will give us our total. 17 math, probability, oops, go back. Permutation, we're doing a permutation now, right? Order matters. There's the answer, 4,080, and we have what? How many we get to make? 1 selection, so our answer is what? The probability now is what? 1 over success over total. Total is 1 over 4,008. That's our answer.
So where was that 3?
1,000. one over. Sorry?
What was that number? Three.
Number 3, 17 to 3, right there.
Okay.
We were selecting a chair, a secretary, and a webmaster. 3 positions.
Oh.
Yeah, 3 positions. Okay. Now, heads up here is if you get the decimal, you do 1 divided by what? 4,080. And what do you get? 2.45. So on what? E to the negative 4th, what does that mean? That means 2.45 times 10 to the what? Negative 4th power. So you what? You move it over 3 places to the left, scientific notation, right? So you go 1, 2, 3, gosh. Well, you have 3 zeros, right? So to 4 decimal places, there's a 4 here, so it'd be what? 0.0002. Yeah, so when it's a really small number, the calculator often puts it into scientific notation. Okay, so just a heads up on that. Remember, the probability's got to be between 0 and 1. So when you see 2.45, you know that can't be correct. Okay, you have 11 letters consisting of 1 M, 4 S's, and 4 I's, 4 S's, and 2 P's. If the letters are randomly arranged in order, what is the probability that the arrangement spells the word Mississippi? So you got what? A choice of exactly 1 arrangement, right? Now, what do we need? We need to get the what? The total, right? Probability is how many choices, successes, you want to get what? 1 sequence of letters that's spelled Mississippi, so 1. So what's the total of all the different sequences? Okay, altogether there are what? 11 letters, and some of them are the same. So this is the what? The formula where you use the duplicate. I call it the duplicate formula. So if they were all different, the answer would be what? 11 factorial, right? 11, 10, 9, 8, 7. But what? You got what? 4 S's, which is what? 4 factorial, right? You got 4 I's, which is another 4 factorial, and 2 P's, which is 2 factorial. Now what? Whenever you have 1, you don't have to worry about it, because 1 factorial is just 1, so when you divide by 1, it doesn't change it. So all you have to do is factorialize the ones that are 2 or more. Okay, the duplicate. Now again, so we would do what? We don't have that formula. The best we can do is we would do 11 math over to probability factorial number 4. There it is. But now what? Divided by 4 factorial, which we know is what? 24, right? And then there's 4 I's, there's 4 S's, so we would do what? Divide by another 24, 4 factorial, and what? 2 factorial is 2 times 1, which is 2. So divide by 2, and there's our answer, 34,650. Okay. Okay. So again, if you do the division, you get it's going to be scientific notation, right, on the calculator. 1 divided by 34,650 is 2.8 times 10 to the negative 5th. There's an 8 followed there, right? So it'd be what? 4 zeros, right? 0.000 and then 29. The 8 would round up to a 9. So there's the number rounded off right at the decimal. Okay, one more example. All right, this is the most difficult one. All right, the last example. Okay. This orientation. And I'm hiding this. Okay, So food manufacturer is analyzing a sample of 400 corn kernels. So the total number is 400, right? In the sample, 3 kernels have dangerously high levels of toxin. So 3 are high levels of toxin, correct? Okay. So how many are going to be whatever, okay? I'll just put okay or good. If there's 400 altogether, there's 3 are that are toxin, then how many are going to be okay? How many kernels will be okay?
397.
Yeah, right. The other 397, right? 400 minus 3. So 397 are okay. What is the problem if you, what? If 4 kernels are selected, so R is 4, the selection is 4, what is the probability that exactly 1 kernel contains dangerously high level of toxin? Okay, what you have to do here is you have to split up the numerator by doing the number of toxins times the number of good ones. You have to separate it. Because what do you want? When you're choosing 4, you want what? Exactly 1 kernel that contains a high level of toxin. So, for toxin, how many are there? There's a total of 3, and you want to select 1. Order doesn't matter, right? As long as we still select it. So for the 1 toxin, it's going to be what? 3C1. Okay? But we're not finished. The other, if we're selecting 4 altogether, then the other 3 are going to be what? The good ones, right? The non-toxin, which how many are those? Are what? 397C3, right? 397 that are okay, divided by what? Probabilities. You got to divide by the total number of samples, which would be what? You don't worry about now, you just do the total number, which is 400. Order doesn't matter, and you're selecting 4. And there's your answer. So you got to do the number of ways to get toxin, 3C1, the number of ways to get 3 non-toxin, 397C3, and then the totals are 400, and you're selecting 4. That's in the denominator. And there's your answer.
You missed that before, so that's one.
Yeah. Actually, yeah. So on the calculator, well, what happens is, let me see, I think the next slide. Okay, go ahead, write it down. Let me know when you're ready.
When it says randomly selected, those seem to tell you the order doesn't matter.
Well, randomly select those. No, because of permutation. No. You just got to here, see the 1 toxin can either be the first one chosen, second, third, or fourth, so order doesn't matter. That's how you would use a combination. Oh yeah, okay, so there it is. So 3C1 for the toxin, 397C3 for the what? Non-toxic. And then you multiply them together, and then you divide by the what? 400C4, right? So 3C1, so you do 3 mass probability, combination is 3, 1. 3C1 is 3, right? 3 ways to get 1 kernel from the total 3. And then times 397C3, right? So you can put in 397 mass probability C3, and then multiply. There's your 31,049,370. And then what? We're going to divide by what? Yeah, the 400C4, right? So divided by 400 mass probability. You can do each one separately if you want. C4, and there's your 0.0296. So if you think of percent, you got about a 3% chance, right? 0.029 would be 0.03, which is about 3%. So 3% chance of getting what? One toxic kernel when you select 4. And again, it's small because what? There's only 3 toxic kernels altogether, right? So you would expect the probability to be very small. All right? So you had to separate the numerator, right? Because you had to get so many toxic and so many non-toxic. In this case, 1 non-toxic, or 1 toxic and 3 non-toxic. Okay? That was a pretty good problem. Okay, that finishes section 3.4. Okay, now, let's do maybe just 1 or 2 homework problems. All right, and then we'll stop for section 3.4. So, okay, homework. 3.4. All right, let's look at number 16. Space shuttle astronauts each consume an average of 3,000 calories per day. One meal normally consists of a main dish, vegetable dish, and 2 different desserts. The astronauts can choose from 10 main dishes, 7 vegetable dishes, and 13 desserts. How many different meals are possible? Okay, so what do we have? We have a main dish, a vegetable dish, and a what? Dessert, right? Okay, now, so we got to find out how many ways of each one and then multiply, right, by the principle, the counting principle. So how many choices for the main dish?
1.
Well, you choose 1, but altogether the choices are what? You have 10. So there's how many choices? 10, right? How many choices for the vegetable dish?
7.
Yeah, 7 vegetable dishes. Now, be careful. How many choices for the desserts?
13.
But you're not choosing 1, you're choosing what? 2. So you're taking 2 out of what? 13. And you're selecting, when you select the 2, like if you choose apple pie, peach pie, does the order matter? If you pick apple and peach are followed by, or first peach and apple, you get the same 2 desserts. Order doesn't matter. So what? It's a combination, because why? You got 13 and you're selecting,
13 and 2.
yeah. See, the other ones, it's just a number because you're only selecting what? 1 main dish, 1 vegetable. But here, you're selecting what? 2 desserts from a total of 13, so you have to do 13C2. Get that number and multiply, right? So be careful. Okay? So what you get is, you can first do, if you want, 13C2. 13 math. C is 3, 2 is 78, and then what was it? Times the number of main dishes is 10, times the number of vegetable dishes, which is 7, right? That's what we had, so it would be what? 5,460. Okay? Make sense? All right, let's do one more number, and we'll stop here for 3.4. In a certain ladder, you must select 4 numbers, and then in any order out of 39 to correctly win. How many ways can 4 numbers be chosen out of 39? Does order matter? What does it say? In any order. So order does not matter, so it's a combination. You got a total of what? 39, and you are selecting 4, right? So 39C4. So we'll do 39 math combination and 4. So the total number is what, 82,251. What's the probability of winning if you purchase what? One lottery ticket. So what you've got one sequence of 4 numbers, so you purchase one ticket, so your success is what? One chance out of a total of what? Yeah, 82,251. Use scientific notation, so actually we can leave it in that form we got. 1 divided by 82,251 is 1.215 times what? 10 to the negative 5th power. Use scientific notation, round to the nearest hundredth, so it would be what? 1 point what? 215. The 1 is followed by a 5, so we round up to
206.
No, to the nearest hundredth. 2 decimals.
22.
Yeah, 22, right. And then times 10, and then it's an exponent, and it's what?
Negative 5.
Yeah, there's the answer right there, negative 5. Okay, so that's kind of nice that they wanted a scientific notation, and that's what the calculator gave. Okay? All right, very good. We will stop for section 3.4 here.